In the previous episode, we saw how to set up a Phoenix LiveView. You find the link below in the description. So we could use this setup to build a simple LiveView gallery app. Before creating our app, I'd like to focus on the Phoenix LiveView primitives, understanding the magic behind LiveView while learning how we can build a simple counter. Once built some confidence and understood how LiveView and its lifecycle work, we'll see in the next episode that the gallery app is just an easy evolution of this counter. So for the purpose of this video, let's put aside the gallery live module and create a new one called counter live, which is going to be our playground. So we do def model gallery web counter live and use Phoenix LiveView. So when a client connects to this view, the first callback to be called is mount. So mount has two arguments, a session and a socket. And in this case, we just return, okay, a socket tuple. So we don't do anything particular, but this function here is usually used to set up the LiveView process and prepare the data needed for the first render. Then the next callback is render, with assigned as the only argument. And inside here, we can use an inline LiveView template like we did in the previous episode with the L sigil, which is a really convenient way if our template is not that big. But if we have a large template, we can move it in a separate LEEX file. So in this case, we just put a counter label with hard-coded value label and a button which does nothing. So this is just static HTML. There are no dynamic parts. Then we go in the router and we add the live counter live. So when we go on this page, we will see the counter live view. So let's run the Phoenix server and go to localhost 4000 enter. And we have our label and our button. Great, we have a working LiveView, but it just renders static content. As we said, there are no dynamic parts, the counter label has just a static 0 value here, and the button does nothing when clicked. Before going ahead making the view dynamic, let's take a moment to see in detail the first part of the LiveView lifecycle. Now, we want to log a string along with the process ID whenever mount or render are invoked. So let's require the logger, and here let's do logger info mount inspect self, which returns the current process ID. And let's copy and paste this here and render and refresh the page just one time. Inspecting the logs, we see that both mount and render are called 2 times with 2 different pits, but we refreshed just one time. What's happening here? The browser, to get the counter page, sends an HTTP GET request to the server, which calls the first time mount and render to render the view and sends back the full page HTML. So this is like doing a curl to this URL, which does an HTTP GET request. And as you can see, we have the full page HTML. And inside the page HTML, we can see the HTML of our view, which is embedded in a div container with some special data attributes like the Phoenix session here and the Phoenix view. These attributes will be used by the LiveView JavaScript library to start a stateful view. By answering with a fully rendered page to an HTTP GET request, we can support clients that do not necessarily run JavaScript, which makes LiveView also great for SEO. When the browser receives and loads the page, it also loads the JavaScript we wrote during the setup here in app.js. If you remember, we wrote these 4 lines, and with LiveSocket Connect, the browser connects to the server with a WebSocket, and the counter LiveView process tracks the changes, pushing the updated dynamic values to the client. We can see under Network that we have a WebSocket connection, and the client sends this message with the session and the view ID. The session string is the same token we have here. When the browser and the server are connected via WebSocket, mount is invoked again to set up the data and render to re-render the view. This second time, only the view HTML is sent back to the browser. So we are now in this situation where the browser and the server are connected via WebSocket. The browser will use this connection to send events to the LiveView process, and the LiveView process will send view updates to the browser. So let's now make the counter value dynamic, the counter value here in the label tag. So let's go back into the mount function, and we use the assign function passing the socket. The second argument is the key we want to use, counter, and the value. So in this way, what we do is to assign to the socket the key counter with the value 0, which return a new socket, and we're going to pass this. So since in this case we are just assigning one value with one dynamic value, we can do this. And we can use this counter here in the template with the @ counter. And we're going to refresh the page, and obviously the result is the same. Let's change here with 10, and we see that now the counter is 10. So to add user interaction, we are going to use Phoenix bindings, which are special attributes. In this case, Phoenix click equal to increment. So when we click the button plus, the browser is going to send to the LiveView process an increment event. So let's refresh and press just one time plus. Have you seen the red background? That means that the LiveView process crashed. Let's see why. We can see that we need to implement a handle event callback in our counter live module. So this callback is the callback we need to handle the event. In this case, increment. You see this string here is the same string here. Then the event and the socket. So what we need to do now, we just need to add 1 to the counter, but how can we do it, and how can we access to the current counter value? So let's go here in mount, and let's do socket equal to assign, and actually let's use a pipe. So what we can do is a little bit nicer socket. So we pipe socket inside assign, and the output of assign is the new socket with counter 10. Let's put it back to 0, and IO inspect to inspect the socket. Inspect returns the socket, the new socket, which we return here. It's exactly as before. The counter is 0 now. but we also print the inspection on the terminal. So refreshing, the counter goes to 0. And as you can see, when we use the assign function, it adds the counter key to the assigns map and the value 0 in this case. It also sets the counter as changed. Let's go back in mount and let's put it as before. Great. So we saw that socket has an assigns map which has a counter key. So socket assigns counter. So what we could do is to create a new socket with the assign socket counter and doing this. I prefer to use the update function. So with the update function, we pass the socket, we say which key we want to update, and we pass the function. So we say, okay, the counter +1, and this return a socket. And we return a no reply socket. Let's refresh and see if it works. And as you can see, just handling here the event, updating the value, we don't need to do anything else. The value and the changes will be pushed automatically back to the client. It really feels like magic that with just few lines of code in the template in handle event, we can have a dynamic counter that is updated on our browser. But let's see how it works under the hood. We have our browser that is connected to the server via a WebSocket connection. And when we click the plus button, an increase event is sent to the counter LiveView process. So here, inspecting the page and going into network WebSocket, we can see the first messages exchanged between the browser and the server. And when we click plus, we see that an event is sent, and the event is increment. So the LiveView process receives an increment event, which pattern matches our handle event implementation that updates the counter. So every time we update or assign a new value to the socket, LiveView re-renders the view and sends back just the changes. If we again inspect the messages, you see here that the reply here, the response, is just some metadata with the new value of the counter. So 6, 7, 8. So you see 6, 7, and 8. And this happens thanks to LiveView that tracks the changes and sends back to the client only what actually is changed. When the browser receives the updates from the LiveView process, it uses the MorphDOM JavaScript library to patch the DOM. I've just switched to the Chrome Inspector because it's easier to see when the DOM is patched. And as you can see, when we click plus, the browser receives the new counter value and only the label tag is updated. So this means that when we have big templates, we will receive only the value that are updated in the LiveView process. In this episode, we've seen the mount, render, handle event callbacks, and the LiveView's lifecycle, inspecting the messages and understanding a bit of the magic behind LiveView. We have now all the elements we need to build in the next episode our gallery app. As always, if you have any question or feedback, please let me know in the comments below. If you like this video and want to be updated when a new episode is available, please subscribe to this channel and to the Poetic Coding newsletter.
Thanks for watching.